Let's discuss the question number 23 from test 5. This is from machine design. So a double riveted lap joint with constructed with 15 mm thick plates is given. So let's draw the front view, the top view of the two plates which overlap. And so there is two rows of riveted joints. So I have just drawn the three across the column. So there are two rows. So rows means this row 1, row 2, and on side view, in the front view, it will appear something like this. And this is the load. I can apply load like this. Okay, so this is my pitch length, small p. Don't confuse with the load, let the load be at 10. Okay, so now what is given is the crushing strength is given, which is 640 MPa. The ultimate shear strength is given, which is 320 MPa. The pitch is given, which is 75 mm, and the diameter is given, which is 25 mm. Okay, so now, as because the crushing and the shear is given, so what we can do is we can calculate the load that is required for shearing and the load that is required for crushing, and then compare the load. So the one which is minimum is something which we need to, which is the maximum that can be applied. Okay, so shear load. So now if you compare per pitch length, this shears and this shears. Okay, and so effectively there is half here, half here. The half here and this half here. So there is one rivet here and there is one rivet here. Half here and half here. So the total shear load will be N into the area of resistance, which is pi by 4 d square, into the ultimate shear strength. So now N is 2 here because per pitch length there are one on each row. So 2 total rivets that support the load. So pi by 4 into 25 square into the 320. So this gives rise to 314.2 kilo Newton. Okay, now let's calculate the crushing load. The crushing load is given again as, so crushing here will be basically when you apply the load force here, this rivet, this part will basically will be crushed. So the area of resistance, the area that will be crushed per rivet is D into T. So it's something like this. You have a rivet here and a hole here. So when you apply the hole is on the plate. So when you apply the force here, so this part of the rivet is something which is locally gets in touch with the hole, with the plate area. So and the local pressure developed is normal, and the crushing area will be nothing but the projected area, which is diameter here into the thickness dt. Okay, so now how many rivets share the load P, the crushing load P? So that will be basically this and this, but per pitch length it will be this and this. So it is half of the one rivet here and the one rivet here. So there are again two rivets. So N into pi by 4 into d square the crushing load is dt. So N into dt into the sigma c. So 2 into d is again the 25, t is again, the thickness is 15, which is given, the thickness is given as 15 the first time, into the crushing, which is 640. So this comes out to be 480 kilonewton So the minimum load that can, the safe load that can be applied is the lowest of these two, which is 314.2, the shear load. So the answer is A. Thank you.